So section R.2, so the review chapter, section 2, is on the distributive property and evaluating expressions. So this should be kind of a review from what you did in Algebra 1. So throughout the year, I'm going to teach you lots of number tricks. So I'm going to teach you ways to do things in your head, like multiplying by like 4 in your head. You would multiply by 2, multiply by 2 again. You're going to learn all of these tricks. So one trick that we don't use enough is the distributive property, which is actually kind of what I was asking Keegan about earlier. I thought maybe he had done 79 times 5 or whatever using the distributive property. So this first example says compute using mental math. So if you have 3 times 49, we need to go way back. Yeah. You already have the answer? Oh, what is it?
Well, I've used the method that you suggested.
Yes.
3 to 50.
So he did 3 times 50 and got,
147.
and then he said it's one less set. So you have, 150, so then one less set is 147. That's exactly right. Good. So that's what we're doing. So there was a, I won't tell the story about the mathematician, but if I have 3 times 49, what we do in our head is we think about multiplying 3 times 50 minus 1. Okay, and if you remember the distributive property, we can distribute the 3 times 50, and we can distribute the 3 times 1. So 3 times 50 we know is 150, and 3 times 1 is 3, so we get 147. And what we're doing when we do this is we're really thinking way back to like 2nd grade when we learned about what multiplication was, or like, I don't know, some of you guys probably learned in like kindergarten kind of what multiplication was. They learn so early these days. And if you remember, your teacher did things like 3 sets of 4. You'd be like, oh, that's 12. 3 sets of 4. I have 4 plus 4 plus 4. Right? Do you guys remember learning it that way? So that's what we're doing. We're saying we have 49 sets of 3. So we instead do 50 sets of 3, and we say, well, what happens if we have one less set? Okay? Brett, are you good? All right, so if I have 6 times 101, we think of 6 times 100 plus 1. So what we're doing in our head is we're doing 6 times 100 plus 1. Well, what's 6 times 100? 600. What's 6 times 1? 6. So in our head, we're saying, oh, I have 594 then. Does that make sense? Can I do this without writing anything now? This next one, 7 times 99. So everybody in their head, think about 7 times what number? 100. So we get 700. Then what? What do you think?
For number 2, wouldn't it be 606? Because 101.
Oh, it was plus, wasn't it? Is that what you're saying? Okay, 606. Yeah, I thought I was doing another minus one. 606. So 7 times 99 is 700, right? Or 7 times 100 is 700. What's 7 times 99 then? It's one less set of 7. So what do we get? 693. Are you able to do that in your head? All right, try the 5 times 98. So we do 5 times 100, so you had 500. What are we subtracting out now? 10. So what's my answer? 490. Done. All right, what about the last one? 186, right? Does this make sense? Do you guys see how that works? So think about these things. Oh, no? You didn't like that one?
No.
Okay. Okay, so if you have 6 times 31, we do 6 times 30, and then plus 1. So we do 6 times 30 first. So what's 6 times 30?
180.
180. And then what's 6 times 1?
6.
So then we add those two things together.
Oh.
So we're breaking apart the problem. Okay, so the distributive property is used for more than just mental math. We use the distributive property a lot in Algebra 1, right? So we're going to simplify these by multiplying like 5n, multiplying 6n, and so on. So see if you remember how to do this. So go ahead and write it on your page and then look up here when you're done. Yep, so then you're going to combine your like terms. So check your first step. So do you guys have 15x minus 10 plus 6x minus 18 minus 10 plus 2x? The mistake that many people probably made, so it's okay if you want to raise your hand and admit that you made this mistake. It's okay. Did anybody not have a plus there at the very end and instead had a minus? That's the biggest mistake that I see. So it's because we have this minus 2 and we're distributing the entire minus 2n. Okay, so be careful to take the sign as well. Okay, So now we combine our like terms. So if you want to kind of underline, sometimes that helps. So I'm like, okay, I got all my x terms. I got 15x, 6x, and 2x. They combine to be 23x. And then I have minus 10, minus 18, and minus 10. So that makes minus 38. Perfect. So on the next one, I'm going to distribute the 5 in, and I get 15 minus 30x. I distribute the next 5 in, I get 5x minus 15. And the last one, remember, take that 4 and the negative. So we get minus 8x minus 12. Did you guys all have that? Now we combine our like terms. So you should get minus 38x. Oh, not 38x. I got another x, don't I? Minus 43x. Did you guys get that? No. I'm really messing up, aren't I? So minus 38x plus 5x. So what do we get? Negative 33x, shouldn't we? And then the next one, be careful. A lot of students that are dyslexic, so if you have trouble with being dyslexic, maybe circle the numbers and circle the sign in front of the number. In front, not behind. It's like 15, the sign that's in front of it is a plus. This next 15 has a minus, and then minus 12. So I'm going to have positive 15 minus 15 is 0, and then minus 12 becomes minus 12. So negative 33x minus 12. Are we good there, Colin?
Yep.
Put your phone away, please. Yeah, Jada?
This probably doesn't really matter so much, but does the order matter? What if you
Nope. Yeah, you could have negative 12 minus 33x. Totally. Yep. So you can write it either way. All right, so now we're going to evaluate the expressions by plugging things in. So we're plugging in A, B, C, all the way through E. Okay, so be very careful on these. When you have a negative, I would put parentheses around it when you're plugging it in. Okay, so the first one I have A, which is 3/4. I'm multiplying by B squared, which is negative 8, and we're squaring it. So notice how I wrote that. Everybody check that you have that, negative 8 in parentheses, and then squared. And then minus D, which is minus 3. So we go through our order of operations, which you just learned last time. So the first thing I'm going to do is I'm going to take care of the exponents. So I'm going to do negative 8 times itself. So I get 64. So then I have 3/4 of 64. Well, you can write 64 as over 1. Let me try it. Cam, you with me trying it?
Yeah.
So we can reduce out 64 divided by 4. Now, if you guys have trouble dividing or multiplying by 4, the easiest thing to do is to do it by 2 instead. So what do you get when you take 64 and you divide by 2? Divide it in 2 pieces, you get 32. Do it again. Divide by 2 again. 16. That's what 64 divided by 4 is. So we can cross out and write 16. So then we have 3 times 16. Mental math skills. Can you do 3 times 16? Yeah, it's 48. So we have 48 minus 3, which is 45. That's it. So one step at a time. All right, so the next one I have C plus D. So I'm going to do negative 2 plus 3. And then I'm taking that result and I'm multiplying by negative 8. So I put that negative 8 in parentheses to indicate that I'm multiplying. Put a little dot as well if you want to. But be careful, don't just leave it as minus 8 with no parentheses, because then people will think, oh, it's subtracting 8, right? It's multiplying. So negative 2 plus 3 is 1, and then we're multiplying by negative 8. So our answer should be negative 8. All right, the next one, number 10. So we have B, which is negative 8, minus D, which is 3. So negative 8 minus 3. And then we're multiplying by E squared. So I'm going to have negative 1, and I'm going to square it. So since E was the entire negative 1, I put negative 1 in parentheses, and then the square on the outside. That's kind of an important thing. Because I could have written it like this. And these two numbers are not equal to each other. Do you understand that? If I have negative and then 1 squared, my order of operations would say to do the square first. So 1 squared is 1, and then multiply by the negative. So negative 1. So this part would be negative 1. This part would be 1. They aren't the same. So be kind of careful with that stuff. Okay, so I have negative 8 minus 3, so that's negative 11. And then I multiply by 1, right? Negative 1 times negative 1 is 1. So my answer then is negative 11. All right, so take a couple seconds and try 11 and 12. I'll pause here. All right, so number 11, so we have D times B minus C all over A times C. So D is going to be 3 times B minus C is -8 minus a -2. And then A times C is 3/4 times -2. Ooh, this is going to be a tricky one. Did you guys have trouble with this one? All right, so the first thing we notice is that we have minus a -2. So those can become positive. Minus a negative is the same as adding. So we're going to get 3 times -6 on top. And then on the bottom, when we combine these, we can write -2/1 if we want when we multiply. So we get -6/4, which reduces. So we could have also reduced the 2 and the 4 before we did it. So you should get what number? -3/2, right? So on the top, we get -18. So we have -18 divided by -3/2, which is kind of tricky. So this is a fraction within a fraction. We call these complex fractions, right? Don't they look a little complex? They look a little hard, right? So when I have -8 divided by -3/2, I instead write it with the little, I call it the old school division sign. Do you guys remember in elementary school when you used that little symbol with the line and the 2 dots? Anybody know what that is called? This is like a Jeopardy question, isn't it? Oh, kind of close. What is it? It's called an obelisk. Obelisk. Yeah, who knew? All right, so anyway, so we have -18 and we multiply by 2 over -3. You can write over 1 if you want. And you can reduce first, or this one's pretty easy if we multiply across the top and then reduce. See how we get -36 divided by -3? What is -36 divided by -3? 12. So how many of you guys got 12? All right, a couple of you. Yeah?
I got -12. So
You got -12.
Where did you get the negative?
Because when you do the negative divided by the negative, it becomes positive. So the reason I had a negative is because I did 3 times -6 here. And then this had a -2 as well. So look for your lost negative. All right, so the next one. So we have A times C to the 4th. So A is 3/4 times C to the 4th is -2 to the 4th. All over D, which is 3, minus C, which is -2, all over E squared, which is -1 to the 2nd. So that will be 1. So we're going to do one thing at a time. So we're going to take care of those exponents first. So -2 to the 4th. So who can tell me? -2 times -2 times -2. What do we get when we do -2 multiplied by itself 4 times? Yeah? Nope. So 32. 16, right? So 2 times 2 is 4. The other 2 times 2 is 4. And 4 times 4 is 16. So we got 16. So we're going to do 3/4 of 16 over 3 minus the -2 over 1. Still one thing at a time. 3/4 of 16. Remember how I told you to deal with fractions the other day? I said think about, 16 cookies or whatever. If I divide it into 4 groups, how many cookies are in each group? There's 4 in each group. So what if I had 3 of the 4 groups? I'd have 12, right? That's what we're thinking when we're doing fractions. So I have 12, and then I have 12 over 3, and then I have minus -2 over 1 is -2, right? So I have 4 minus a -2, so plus 2. So our answer should be 6. Tricky. Yeah. Yeah, you're fine. You don't have to ask. All right, so the next one. So I have -b, so -8 is 8. I have a is 3/4 plus c minus d is -2 minus 3, and then squared. So we're going to do one thing at a time. So this involves some fractions. So let's start with the -2 minus 3. So Cassie, what do you think? -2 minus 3 is -5. What do we get when we square it? 25. So we're at 25. So we did -5, we squared it, we got 25. So then here's the gross part, because we have 3/4 plus 25, which isn't very fun. Right, so we're getting common denominators. How could I rewrite 25 so it has a common denominator? Yeah, isn't it 100 over 4? That's the same as 25, right? So we have 8 times 103 over 4, which again, you can think of it as 8 over 1 if you want. So where are we at? So Rhett, what do you think? So 8 over 1 times 103 over 4. What can I reduce out? What do we get for our final answer? The 8 and the 4 becomes a 2, right? So then we have 2 times 103. Can you do it in your head? 206. Perfect. Yep, good. So our answer is 206. All right, tricky, aren't they? I don't keep it easy on you. And in geometry, I like to try some tough stuff. I like to make sure you're kind of building on your Algebra 1 skills. So we got to see if you know this stuff. All right, so sometimes it's best if you simplify expressions before plugging numbers in. Okay, so don't write any of this, but everybody look up here. So if I was plugging in 2 and negative 1, it would be gross, because here's what I would have. Lots of parentheses and lots of math that I don't really want to do, right? Look at that. Isn't that kind of annoying? Right? So the easiest way to do this is to simplify, simplify, simplify before we even start, before we plug numbers in. So if I multiply the x in, I have 7xy squared minus 3x squared. Do you guys remember that from Algebra 1? Like x times x is x squared and so on. All right, so then I have plus 6x squared minus 14xy squared. So we need to combine what we call like terms. So you guys can write this down now. So I told you to stop writing and then I wanted you to write again. So if you remember in Algebra 1, like terms not only have the same variable, like I can't combine like a 7x and a 2y because they don't have the same variable. So not only do they have the same variable, but they're going to have the same exponents on those variables. So if you look at this first one, an xy squared term, it combines with any terms that are xy squared. So it's going to combine with this. So make sure you take that sign in front of it, right? So I have 7xy squared added to negative 14xy squared, so I get negative 7xy squared, 7 minus 14. And then I have my x squared terms. I have negative 3x squared plus 6x squared, so I get plus 3x squared. That's our answer. Oh, I guess not quite our answer, is it? You're like, wait a second. Okay, so that's our simplified form. So we've simplified as much as possible. Now we're going to plug these numbers in. So now plug in x equals 2 and y equals negative 1. So we're going to have negative 7 times 2 times negative 1 squared plus 3 times 2 squared. Okay, we're going to do our order of operations. So we're going to do our exponents first. So Maya, what's negative 1 times negative 1? So we have 1 there. Times negative 7 times 2. Can we do all that? So 1 times negative 7 is negative 7. Times 2 is negative 14. So all of that together is negative 14. So how about the next one? So let's see. What do we think? Yeah, so we have 2 squared is 4 times 3 is 12. So our final answer is negative 2. All right, you guys try 15. So I'll give you a second to try it. All right, so first we're going to try to simplify. So we're going to have our 2x plus or minus 3xy plus 28xy minus 21x squared plus 4x squared. Did you guys have that for the first step? So combine our like terms. So let's look for any x terms. Well, it looks like just the 2x, right? Any xy terms. So I have an xy and xy, and that's it. So I have plus 25xy, right? Negative 3 plus 28. And then the last one I have negative 21x squared plus 4x squared. So I'm going to have negative 17x squared. Did you guys all get to that point? Now you plug in the numbers. So we're plugging in 2 for x. So 2 times 2 plus 25 times 2. Y is negative 1. So it looks like we're going to have 4 minus 50, because it's 25 times 2 is 50 times negative 1. And then this next one, 17 times 4. So the easiest way, as I said, to multiply by 4 is to multiply by 2 and then multiply by 2 again. So 17 times 2 is 34, right? We just double it. 34 times 2 is 68, so we have minus 68. So you can combine these in different ways. If you want to do the 4 minus the 50, you get negative 46, negative 46. And then you can add that to negative 68, right? And combine those numbers. I think you should get, what is that, 114, negative 114? So yeah, your answer should be negative 114 in the end. Did anybody get that? All right, good, awesome. So you guys are really good at algebra. All right, so we're going to stop there, and then I'm going to grab you guys have your homework.